Hello learners, welcome to Unit 6 in the course Introduction to Abstract Algebra. In this Unit 6, we are looking at algebraic structures. That includes the groups. We also look at rings, integral domains, and then fields. So in this session 1, we are looking at algebraic structures. I am Munkaila Dasmani, your course instructor. By the end of this session, you should be able to describe an algebraic structure. You should be able to mention the various types of algebraic structures and also give at least one example of each type of the algebraic structure. Definition of algebraic structure. Abstract algebra is basically the study of specific algebraic structures and their properties. Algebraic structures are so numerous today that we cannot list them all in this session. In particular, there are sometimes multiple names for the same structure, so it depending on the field you belong to. So algebraic structures may be viewed in different ways. Thus, the common starting point is that an algebraic structure incorporates one or more sets with one or more binary operations or unary operations satisfying a collection of axioms. So I understand you know the meaning of axioms. If you forgot about axioms or your set, go and do your revision in the Unit 1. Also, axioms, you can also read the course Nature of Mathematics to understand better there. Another branch of mathematics, which is known as universal algebra, studies algebraic structures in general. So from the universal algebra viewpoint, most structures can be divided into varieties and quasi-varieties depending on the axioms used. Good. So algebraic structures appear in most branches of mathematics, and studies can encounter them in many different ways. So let's look at the study of algebraic structures. So in the first one we are looking, so beginning study, you in first degree. So in most universities around the world, some look at groups, vector spaces, and fields. The first algebraic structures encountered in subjects as linear algebra. I remember my first linear algebra course I did in UCC. We covered vector and then also field. We covered them there. So they are usually introduced as sets with certain axioms. So that's the beginning study. So study of algebraic structures. In advanced study, students may encounter the following. Abstract algebra. So abstract algebra studies properties of specific algebraic structures. So that is this course we are doing, abstract algebra, introduction to abstract algebra. Okay. Universal algebra. It also studies algebraic structures abstractly rather than specific types of structures. Now we also have category theory, and this studies interrelationships between different structures, algebraic and non-algebraic. So to study an non-algebraic object, is often useful to use category theory to relate the object to an algebraic structure. So category theory is also very, very important. They are all part of the abstract algebra or algebraic structure. So abstract algebra is a subset of the algebraic structure. So it's very, very important. That's why mathematics we divide it into two. Either you go in for the pure maths or you go in for the applied mathematics, but they both are related. You study both of them, then you become best mathematicians. Types of algebraic structures. There are many types of algebraic structures. An algebraic structure may use any number of sets and any number of axioms in its definition. So the most commonly studied structures, however, usually involve only one or two sets and one or two binary operations. So we will give a brief description of each type in the next videos. So we'll begin with the first one binary operation on one set. So the most common or key structure is called a group. So groups are key structures under this type, that is one binary operation on one set. And we also have abelian groups. abelian groups, and they are an important special type of group. So you learn what group is in the next session. We will look at groups. So abelian groups are important special type of group. So you can read ahead and then we will talk about groups. Actually are very important because other structures involve weakening or strengthening the axioms for groups and include. So the groups is the first one and then the others follow. So the others are just giving much more about groups. It's either weakening or strengthening the axioms for the groups. Example is abelian groups. So we also have semigroups and monoids. Semigroups and monoids. These are like groups, except the operation need not have inverse elements. So we learn about that in the second session. But you can also find yourself what is the meaning of semigroups and monoids. I'm sure you've gone through them before. So they are like groups, except that the operation need not have inverse elements. Another one is the quasi-groups and loops. These are like groups, except the operation need not have or need not be associative. So in the quasi-groups, associativity is not defined. Magmas in plural, magmas. These are like groups, except the operation need not be associative or have inverse elements. Then we say that it's a magma, or that is magmas for plural. Then we have semi-lattice. This is basically half of a lattice structure. So we're looking at the lattices in general. They are very important. Okay, so another one is two binary operations on one set. So the main types of structures with one set having two binary operations are rings and lattices, which I've highlighted with red marker or red, bold it red. So the rings and lattices are very important. So now I've said you should look out for what groups are. Here you should also look out for what rings and lattices are. I know we'll go through before this course ends. One major difference between rings and lattices is that their two operations are related to each other in different ways. So in ring-like structures, the two operations are linked by the distributive law, but in lattice-like structures, the operations are linked by the absorption law. So the axioms defining many of the other structures are modifications of the axioms for rings and lattices. So these algebraic structures are very important, what you should know as a mathematician. Okay, so we are looking at two binary operations on one set. So rings. The two operations are usually called addition and multiplication. So when you have rings, then think of addition and multiplication being two binary operations. So commutative rings are a special important type of ring where the multiplication operation is commutative. So we learn something about commutative rings. We also have integral domains and fields are especially important types of commutative rings. So we also hear something about commutative rings. Good. So read about them. They are very interesting. Non-associative rings. These are like rings, but the multiplication operation need not be associative. So it does not define associativity. Okay. And then the next one is semi-rings. The name implies semi-rings, half rings. So these are like rings, but the addition operation will not have inverses. Once the addition operation is not having inverses, then we say that this is a semi-ring. Okay. And then we have near rings, something very closer. These are like rings, but the addition operation need not be commutative. So commutativity is not defined under near rings. Lattices. The two operations are usually called meet and join. So we have laticoid, meet and join, commute. That is commutativity is defined but need not associate. So once the commutativity is defined and associativity is not defined, then we say laticoid. And we have skew lattice. The skew lattice meet and join associate but need not commute. That is commutativity is not defined. So very interesting. You see that the ability of mathematics and more importantly pure mathematics, they are very interesting. Likewise, applying mathematics are very, very interesting. You can apply math in everywhere, in every part of this world, every place.
Okay, so two binary operations and two sets. We may have something like vector spaces, modules, group with operators. Good.
Okay, so the session review. Explain at least two types of algebraic structures. You can mention them, and then you can also explain more than that with specific example. So make sure you read more on that algebraic structures. They are very, very important. Thank you for your time in this session.